Hi friends, welcome to follow up. Let's have a look at problem 268, missing number. This is a daily challenge problem, and also its logic is very straightforward. So in this video, we are going to present two formats of codings. So more precisely, we provide one solution based on simple computation, and the other we are going to use bitwise operation. So we are going to use exclusive OR. So the question is the following. So given an array called nums containing n distinct numbers in the range 0 and n, both inclusive. So from 0 to n, if we include the two n's, there are n plus 1 numbers, right? So we want to return the only number in the range that is missing from the array. Here we have three examples. In the first one, so from 0 to 3, we have 0, 1, 2, 3. So 2 is missing. And in the second one, the length is 2. So we have 0, 1, 2. So 2 is missing. Well, in the third example, so the largest number is none. So we have 0, 1, 2, up to none. So 8 is missing. So the constraints are the following. Here, the length n of the list is bounded above by 10 to the power 4. And the numbers are in between 0 and n inclusive. All the numbers of nums are unique. So this problem, if we want to solve it, is rather straightforward. Here let's look at the follow-up. So could you implement a solution using only O1 extra space and use On time, right? So this problem actually is rather direct in the sense that it already told us that so the range is in between 0 and n, both inclusive, and then there's one missing. So actually we can compute the sum of those numbers and then minus the sum of the nums list. Then the difference will be the number missed. So we regard this one as one solution, so some simple algebra, right? So for this, we didn't, actually it's not sort of a coding exercise. So here, let's see, we want to sum from 0 to n, right? N where n is the length, right, of nums. Let's do this. Let me do nums. This is length. So this is just introduce this variable just for some convenience. Then we sum from 0 to n. So this is rather simple to compute. The sum will be, let me use s, as the first term plus the last term, and then times the number of atoms. So that is from 0 to n plus 1 to n is n plus 1 terms. And then integer division by 2, right? Then the sum of the list will be sum of nums, right? Then you just need to return s minus s list, right? So let's do a quick test. Why it's running too slow? So let's submit that. Yeah, it passes the cases. So let me simplify this a little bit. So we just need to return. So let's copy this part. So I'm going to call this one version v1, and this is version v1 prime. Let's see. We just need to have this in, so we just need to return. So this, let me put it minus this sum. That will be sufficient. So if you replace the n by the length, so you can write a one-line solution. So let's submit that. So here, missing number, do you mean? So here, we need to first use this function signature to test. Let me change this one to be v1, so hyphen or bar, so something like that. So next, what we want to do is we want to introduce a solution using exclusive OR. So because this problem, if we want to use exclusive OR, so you will see this problem is sort of made to use exclusive OR. first let me explain the exclusive OR, so XOR. So basically this operation says that if you compare the two bits, right, so if they are the same, you are going to result a 0. Otherwise you're going to result 1. So for example, you have 1 and you do exclusive OR with 1. So in Python, the corresponding operator is this 1. So if you do 1 and 1, because they are the same, so you get 0. Similarly, if you do 0 exclusive OR with 0, so you get 0. But if you do 1 exclusive OR with 0, you get 1. And 0 XOR 1, you get also 0. So this second line basically tells us, because this two lines, 1 and 1 will give 0. 0 and 0 gives 0. So right, so for sure this is the rules indicates actually. So the exclusive OR is commutative. In other words, A exclusive with B equals B exclusive OR with A. This is a commutative. This is the one thing. And also it's associative. So this commutative. So this is also associative, right? You just need to use the rule. So A XOR B XOR C. Because it's associative, we can write like this, or you write in the n terms, right? So it equals, so you can do first with the second two terms. So let me do this. And then it also equals this one. So the properties of exclusive OR is the following. So if you have an integer, say you do exclusive OR with a 0, you get A for sure, right? So this is 1. And then you do exclusive OR with itself, you are going to get 0. So this is a cancellation property, right? So this is very easy to look at. So if you write A into binary representation, then the A and A for sure have the same binary representation. So in each bit position, the digits or the byte are the same. So you are going to get always get 0. So for this problem, we can use exactly the cancellation property. So here is for example, you have 1 and 2 and 3, so and 4. So you do exclusive OR, let's see, with 0, right? So then this is, for example, from 0 to 4, right? So if I have 3 missing, right? So then the list will be something like 4. So in any order, the order actually does not matter, right? And then what we are going to do? So we first, because we probably know the range, we can get this result of exclusive OR. Then we are going to use this one and exclusive OR with all the elements in this list. That is exclusive OR with 0, with 1, with 2, with 4, right? So because 0 appears twice, 1 appears twice, and 4 appears once. So 3 appears, 4 appears twice. So 3 appears once. So you get 3. So that's the logic. So for sure, you know, this is O1 space, and basically you just compute that. So if you do sum it, we can think of it as On. But for this version of solution, we can first get the exclusive OR. So you can use reduce method to get the exclusive OR, or you can just do it from scratch. Let's see the result, the sum, let's say 0. So then I just need to for I in range, say 0 to, let me write, say n length of nums. And then so here, because n is inclusive, I write n plus 1. You can also do not need to write the 0, but let's specify it here. So to emphasize the start and the end is n minus 1, so we stop at n, right? So then we do s exclusive OR with this I, right? So once we have this, in order to get the result, we just need to do exclusive OR with all the elements in nums. right? So basically for y in nums, then s exclusive of is this y. So after we finish this, we just need to return the current state of s. This s will be the missing number, right? So let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic cases. So I guess that would be about it for this problem. So here I want to give a question for you to think. So what's the following operation doing? So for example, given the integer, right? I want to x and add with respect to negative x. So here negative x is 2's complementary of x, right? So yeah, you can put your thoughts or comments for this question in below the video. See. So here actually I can give you a hint. So this operation actually can be used in Finwick tree, right? So if you know the implementation of the Finwick tree, you mean this question might immediately remind you of the role of this operation. But if you didn't see Finwick tree before, you can think of this question. So with that said, I guess that's about it for the current video. Thank you. So I forgot one thing. So in the next question is a follow-up question. We're going to look at problem 201. So in this question, we are going to use, we want to do something related to bitwise add, right? So yeah, that's about it. Thank you.